Hello students, welcome to the online session of Database Management System. In today's session, we are going to study about different anomalies in Database Management System and need of normalization. The learning objectives of today's session are, after learning this session, students will be able to identify the anomalies in a database system and students will be able to resolve different anomalies. So first, we'll start with the normalization. Normalization is the process of organizing data into the database to reduce data redundancy. We already know data redundancy means duplication of data in different tables or in single table itself. When number of copies of same data are created, then it is called as redundancy of data. So to reduce this redundancy, to minimize the duplication of data in database system, normalization process is carried out. And this normalization process is also used to avoid insert, update and delete anomalies. Anomalies are nothing but the problem that occur while inserting, updating or deleting data in a database system. So basically in normalization process, we divide larger table into smaller related table. That is, whenever a table consists of many attributes, or whenever table size is very large, then there may be a problem of data redundancy, or there may be a problem of insertion, deletion and updation. So to avoid this, we divide our larger table into a smaller related table by using normalization process, and then we link all those divided tables together by using relationships and by using common attribute. Okay, so in entity relationship diagram we have already studied what is meant by relationship. It is the association between different entities. That is, we can say it is association between different relations, and common attribute is related to referential integrity constraint. That is, it is a foreign key by using which we can access data or we can relate more than one tables together. Okay, then this normalization is a stepwise process, or the normalization process consists of different stages, or we can say there are different normal forms through which we can reduce redundancy and through which we can reduce different anomalies that occur while inserting, updating and deleting data. Okay, so those normal forms are first normal form, second normal form, third normal form and Boyce Codd normal form, that is BCNF. So these four are the basic normal forms, means after which we can get a normalized database that has less redundancy and that doesn't consist of any problem like insertion, updation and deletion anomalies. Okay, so now one by one let's see what is anomaly. So anomalies are nothing but the problem that occur in poorly designed or denormalized database. When our database system is poorly designed or badly designed, then these type of problems or these type of anomalies occur in a system. Okay, when we store all data in one table, and when we store that data without identifying functional dependency or without identifying proper relationships, then there may be a problem of these anomalies. Okay, and when we store all data into single table, then it also results in a data redundancy. So in database system we have three types of anomalies, that is insertion anomaly, update anomaly and delete anomaly. Okay, so one by one we'll see each of them in detail. So first we'll see insertion anomaly. It is a problem when we want to insert some data into the database system, when we tend to insert data into a relation, but we can't insert that data due to unavailability of some other data. Okay, for example, see, this customer table is there. So customer table consists of attribute customer ID, customer name, phone number, then product ID, product name, order date, price and brand. So these all are the attributes of customer table. Now when we look at this table, we can clearly say that this table is for customers who have ordered some product. Okay, so this table consists of information about customer entity, and it also consists of information about product entity. Okay, so when we carefully observe this table, we can say that there is a lot of redundancy in a table. There is a duplication of data. Okay, see, product P1 is ordered by two customers, customer ID 1 and customer ID 2. Both have ordered this P1 product. So it consists of product ID for P1. Okay, so that is okay, but it also consists of product name, which is repeated twice. It also consists of price. It also consists of brand. So unnecessary these product name, price, brand, these details are repeated twice. Okay, so there is no need to incorporate, or there is no need to include these details in a single table, because if we know the product ID, then we can access product name, price or brand from another table also. Okay, but since here we are having single table, it results in a redundancy of data. Similarly, for product P3, it is ordered by two customers, customer ID 1 and customer ID 2. Okay, so with that product P3, with that order, the product name, price and brand, these information is also repeated here. So it is called duplication of data, or it is a redundancy of data. Okay, and see, here if we want to insert data for new product, if we want to insert information of new product into the table, but till that product is ordered by any customer, we cannot insert that data. Okay, because here see, customer ID and product ID is a candidate key. Okay, means by using this combination we can access each row uniquely, we can identify each row uniquely. Okay, so here if we consider this candidate key as a primary key, then customer ID cannot be null, and product ID also cannot be null. Okay, so see, whenever we want to insert data for new product, that product must be ordered by any customer, then only we can insert data. Okay, without customer ID, without name, without phone, we cannot insert product information into the table. Similarly, if we want to insert information about new customer, then also we need to insert data for product here. Okay, until that the customer has ordered some product, we cannot insert data about customer into the table. So this is the insertion anomaly, that is, we cannot insert data for one entity until we have corresponding data for another entity. Okay, so this is insertion anomaly here. So this customer table consists of lots of redundancy. That is, if a new customer is added here and that new customer has ordered product P1 again, that is, that new customer has ordered printer again, then we need to insert product ID. Okay, so that is okay, we insert product ID, but along with product ID we need to insert product name, price and brand again. Okay, so this that will again increase the duplication of data, that will again increase the redundancy of data. So this is insertion anomaly and redundancy problem in this customer table. Now next problem is update anomaly. See, update anomaly occurs when information related to any product or customer is to be updated in our table. Okay, see here, if I want to increase the price of any product, then suppose I want to increase the price of product P1. Now P1 product is ordered by two customers here. Okay, so suppose here in our customer table 50 customers have ordered product P1, then in that case I need to update the price of P1 product in 50 rows. Okay, and in case by mistake if I forget to update any of the rows, if I forget to change the price of P1 product in any of the rows, then it will result in a inconsistency. Okay, so when redundancy of data is there, or when duplication of data is there, while updating the data, while updating any attribute, we need to be careful that we are updating all rows. Okay, if we by mistake forget to update any of the rows, then it will result in a inconsistency of data. Similarly, if we want to update any customer information, and if that customer has ordered number of products, then this table will consist of that much rows for that customer. If any customer has ordered suppose 10 products, then it will consist of 10 rows for that customer. And if we want to change the phone number of that customer, then we need to update that phone number in all 10 rows. And if by mistake we forget to update any of the rows, then it will cause inconsistency. Okay, so this is update anomaly. Now let's see what is delete anomaly or delete problem in database system. So delete anomaly occurs when deletion of data related to one entity may cause data deletion of some other related entity. Okay, again consider same table which consists of information about customer and product. Here, if we delete information of any product, then it will delete the information of customer also. Okay, now see here, scanner is the product having product ID P2. Now this scanner product is ordered by a single customer, that is customer ID 3 has ordered this product scanner. If I want to delete the information of scanner, if I want to delete this product from my product list, then after deleting that product from the table, the customer information, that is customer ID 3, name and phone number will also get deleted. Okay, so this will be a loss of information or loss of data. Similarly, if I want to delete the information of any customer, then the corresponding information of product will also get deleted. Here see, scanner is ordered by a single customer. Suppose I want to delete the information of customer 3. Okay, so it will delete the information of product also. Okay, so this is delete anomaly. So delete anomaly occurs when we try to delete data for one entity, but it will delete data for another related entity also. Okay, and these type of problems occur, these insertion, deletion and updation anomalies occurs in a database system when we have larger table and when we store related data into single table itself. Okay, so what is the solution for this problem? So how can we remove these anomalies? So we can remove these anomalies by dividing larger table into smaller tables, and then we can give relationship, or we can relate those two tables together, or those smaller tables together by some common attribute. Okay, so this is the customer table that we are already having. Okay, so see, we can remove, we can split that customer table into two table. Okay, so first table will be the customer table, which consists of information about customer like customer ID, customer name, phone number, product ID and order date. Okay, so that is my first table. And my second table will be product table, which consists of information about product. See, it consists of product ID, P name, price and brand. Okay, so here we have divided our larger table, okay, larger table into two tables. One is customer table, which consists of information about all customers, and second table is product table, which consists of information about all products. Now if you carefully look at these two tables, then you will come to know that we have minimized the redundancy. That is, your customer table consists of only product ID. Okay, so only product ID is duplicated here. Okay, but product name, price and brand, these values are not duplicated, means we have reduced the redundancy. Okay, similarly, insertion problem is also not there, because if you want to insert data for new product, then you can easily insert that data into product table, though that product is not ordered by any of the customers. Now see, customer ID, here for customer table, customer ID and product ID combinedly, this is a primary key. Okay, and in product table, product ID is the only attribute which can act as a primary key. Okay, see here, if you want to insert data for new customer, then you can easily insert that data into customer table, and if you want to insert data for new product, then you can easily insert that data into product table, even if product is not ordered by any of the customers. Let's talk about update anomaly. If you want to increase the value of any product, if you want to increase the price of any product, then you need to update single row only, and that is the row of your product table. See here, if I want to increase the price of product P1, then I can directly increase that price from product table. Since my product table consists of a single row for P1 product, there is no duplication of products here in product table, so I need to update single row only. Okay, so there will not be any inconsistency. Then this is how we can remove our update anomaly or update problem. Now let's focus on delete problem. If I want to delete any data for product, if I want to delete any information for any product, then I can easily delete that data from product table, but my customer information will be as it is in customer table. Similarly, if I delete data for any customer, but the product information will be saved in a product table. Okay, so this is how we can remove anomalies from the database system, from the table, by dividing larger table into smaller tables. Now here product ID is the common attribute through which we can relate these two tables together. Okay, through which we can access data. By using this common attribute, we can access data from both the tables. Means here these two, though we have divided these one larger table into two tables, still those two tables can be joined together. Those two tables can be related together by using common attribute, that is foreign key, which is a which is a product ID in this case. Okay, so this is roughly called as a normalization process, that is dividing larger table into smaller table to remove, insert, update and delete anomalies, and to remove or to minimize redundancy or duplication of data. Okay, so in today's lecture we have studied what is normalization, then how to remove, insert, update and delete anomalies. See, insert anomaly means whenever we try to insert data for one entity, but we cannot insert that data because we don't have data for the other attribute, for other entities attribute, then insertion anomaly occurs. Updation anomaly occurs when we want to update data for any entity, and that entity is duplicated number of times in a table. We need to update those number of rows, and if we forget to update any of the tuples, then there will be a inconsistency of data. So that is updation problem. And deletion problem occurs when we try to delete data for one entity, but it will also delete data for another entity. Okay, and by dividing, by splitting larger table into smaller table, we can minimize redundancy, we can remove or we can avoid all these anomalies. So this is all about today's session. Thank you.